In the next phase of processing, the OCR kicks in. Whenever a new image is queued, we try to retrieve the associated classification for this region where a number plate is supposed to be present. If we do find a classification for this region, we try to process it further. Otherwise, we mark this potential candidate as not classified because we could not understand what kind of number plate it was. So if we do have a classification, we then try to figure out where the text could be given this number plate. Let me open this file so that I can explain this a bit better. So the function itself is very simple based on the type of number plate we have. For instance, I have the classifications for a private broad number plate we have in Qatar and a private normal number plate we have in Qatar. The normal and broad differ only in terms of width and a little bit of height. So I just return the part of the image that I believe should contain the text given what kind of number plate it is. This is very important because it automatically cuts down on a lot of false positives and things that we really don't need to process. Once we have this text region of interest, this is again a small image. We call another utility function which is find region of interest. This is a bit of a lengthy function and it deserves a session of its own, so I will not go into a lot of detail over here, but this is the part of the code that I'm trying to improve, and I'm trying to remove all aspects of OpenCV from here and move everything to a deep neural network based approach. Until that happens, we have to stick with this. You can read through, try to understand. If you have any questions, you can post it on the GitHub repository or you can contact me on LinkedIn. So coming back, once we have the region of interest that we believe contain letters, we try to classify each one of these by passing them onto our neural network. And once we have a response, we do what we do in other services. We just append those to an OCR block for use later. At this stage, we update the database and we publish a message onto another exchange which can be subscribed to by others to receive the OCR events. This is the brief overview of the modules in OpenLPR and how they are structured, what sequence are they called in, what the general code layout is. If you would like to see what happens after we have performed OCR, you can refer to other videos, such as one recently published by me, which talks about integrating any Modbus compatible device with OpenLPR system, which shows a demo of configuring Node-RED to writing a business logic that monitors the OCR events, and if it finds a match, it just sends an open command to a Modbus compatible barrier gate. So the last part of the discussion is Docker. You should have a basic understanding of what Docker is, what containers are, what images are, to fully understand what I'm going to be talking about next. If you don't know the subject, I strongly encourage you to go and learn about it. It's a very fun subject to know of. Microsoft and others have free courses that you can take, exams you can pass to earn your certificates for your basic fundamental knowledge on Docker, DevOps and related aspects. But just to describe in a nutshell, Docker allows you to package each one of your services individually to scale up, down, do fault tolerance recovery, and an abundance of other features are provided. So for each of the OpenLPR service, we have an associated folder here for Docker. For example, I'll talk about the FTP service. I am telling Docker to start from Python 3 base image, and I'm telling it to open to add files from these locations onto the destination file system. And I'm then telling that whenever we start a process in this container, the working directory is going to be this one. Finally, I'm installing some dependencies as part of the file we've already added before, and I'm telling Docker that this service exposes the port 2121 so that if somebody tries to access the service from the host system or from the host network, it should be routed to this particular port. Of course, once you do understand Docker, you will know that you need to do a port mapping or make this on a host network for this to actually work. Eventually, we describe the entry point, which says that when somebody tries to start up this container, this service should be executed, which happens to be the FTP service. There is also a Docker Compose file present, which can be used to deploy all of the services. If you refer to the GitHub repository, you will find that using a couple of commands, you can easily start all of the Open LPR services. These services expect to find the images to be already present on your machine. I haven't yet published the Open LPR images to the Docker Hub. The images for Open LPR are in this override file. To get these images, you just have to execute one of these shell scripts. If you're on a Windows system, you can execute this batch file. If you're on a Linux system, you can execute this shell script. So this is going to produce all these images in your local machine, and then you can use a Docker Compose up command in this folder to deploy all of these services and explore the system. Or you can use this utility script to do the same if you're not very familiar with Docker, but still this script assumes that the images have already been built. Thank you very much for your time and for listening to this discussion and introduction on Open LPR. In the next session, I will briefly go through how we can train our own models, the deep neural network models, to be used with Open LPR system. Once you have done that, you will have something similar to this. We will be producing 3 different models: one for the classification of letters and numbers, one for the detection of number plates using these 2, and one for the classification of the type of number plates, which is over here shown as plate classifier. The difference between these is that the detection is done using TensorFlow's default shipped object detector utility scripts, while the digits and the plate classifier are some custom classifier deep neural networks that I have designed and shipped as part of Open LPR. So stay tuned for the next time. Thank you once again.